I'm Bryan DeLuca, and I am here with Sarah Gross at the Keysight booth at APEC. Sarah, what do you got going on?
All right, we just launched these brand new isolated probes. They are 1 week old.
Ooh,
so
really
it's a
new. Really
newborn, yeah.
Yeah.
So we've been working on this for a while, excited to bring this to market. It's optically isolated, so it has galvanic isolation from the scope itself.
Okay.
And that has many benefits to it, especially in terms of power electronics. You might be familiar with standard differential probes. So this is a differential probe, but has more common mode rejection, way more than you'll find, up to 100 billion times in some cases than a regular differential probe.
So what do engineers need to know about using these new probes?
Yeah.
So when they're testing something, what do they need to know?
Okay, first off, it's not handheld. I need to say that and make sure everyone knows. But for this example, in this demo, they're measuring a high side gate. That's where we're going to see a lot of use cases for this kind of probe. Specifically, this is a silicon carbide switching device.
Okay.
So it's higher frequency. In most cases, like this board can go up to 800 volts of switching.
Okay.
And the probe itself can do differential measurements up to 2,500 volts. And you're going to see that in applications like EVs, car batteries, power conversion, grid-connected devices, other robotics, potentially, automation.
Okay.
High voltage, yeah.
So you mentioned this is looking at GaN, right? Is this specifically designed for GaN? Or?
So this one's looking at silicon carbide, but gallium nitride, no worries. Gallium nitride is another wide bandgap semiconductor. That is a very key application area, but not specifically those either. We have some other customers using regular silicon or other classic MOSFETs. It depends on the architecture mostly, and then how much common modes on their source voltage, and how much are they trying to take out those common mode effects and measure the floating voltage.
Yeah. Now, you had another demo you wanted to show us.
Yes, I do. We have our other new oscilloscope that has super low noise, so I'll show you that.
Let's go take a look at that.
Okay.
So this is your newest scope. What can you tell us about it?
All right, this is a 14-bit oscilloscope, so it has super low noise, and that enables you to make very low voltage measurements, important for low voltage ripple measurements, for example. And what we're showing is actually a 100 microvolt signal. Okay. And we don't have any other scopes that can measure a signal that small. That's how low the noise floor is, that you can visualize this, and it even goes down to 13 microvolts of noise.
Okay. And this is the newest one in the family, correct?
Yeah, it came out last September for Keysight. It's called the HD3 High Definition family, and it's more of a general purpose, carry it around the lab. It can do protocol decode. It can do all of the basic measurements that you're going to need. The other scopes we just showed are more of an analysis based. Those are the 8-channel scopes as well, and this comes in 2 or 4 channels.
Well, Sarah, thank you for showing me what you have going on.
Thank you. Thanks so much.